We've all been captivated by the awe-inspiring power of explosions in movies and on television. But have you ever stopped to consider the science behind these dramatic events? Explosions, in their purest form, are fascinating displays of energy transformation. They occur when a substance rapidly changes its state, releasing a tremendous amount of energy in the form of heat, light, and a rapidly expanding volume of gas. Imagine a balloon being inflated until it bursts. That sudden release of pressure causing the balloon to shred apart is a simple way to visualize the rapid expansion of energy during an explosion. This sudden release of energy creates a shock wave, which is the hallmark of an explosion. The shock wave is the rapidly expanding pressure wave that can cause significant damage. Think of the shock wave as a ripple effect, but instead of water, it's energy radiating outward from the explosion's epicenter. Understanding the science behind explosions is critical, not only for our safety but also for harnessing their power for various applications. From controlled demolitions to the internal combustion engines that power our vehicles, explosions when properly controlled play a significant role in our lives. Among the different types of explosions, chemical explosions are the most common. These explosions occur due to the rapid chemical reactions that release a significant amount of energy, often in the form of heat and light, driving the rapid expansion of volume. A simple analogy is the lighting of a match. The striking of the match initiates a chemical reaction between the match head and the oxygen in the air. One of the well-known examples of chemical explosions is the detonation of dynamite. Dynamite utilizes highly unstable compounds like nitroglycerin, which when detonated rapidly decompose, releasing a massive amount of energy in a fraction of a second. This sudden release of energy is what causes the destructive power of dynamite. But it's not just dynamite. Many other substances can cause chemical explosions. Flammable materials like gasoline, natural gas, and even finely dispersed dust particles in the air can explode if they come into contact with a spark or flame in the presence of oxygen. Understanding the properties of these substances and how they react with each other is crucial in preventing accidental explosions. Now let's delve into the realm of nuclear explosions, which are far more powerful than their chemical counterparts. These explosions result from the splitting or combining of atoms, processes known as nuclear fission and nuclear fusion, respectively. The energy released in these nuclear reactions is millions of times greater than that of chemical reactions. Nuclear fission, the process harnessed in atomic bombs, involves splitting the nucleus of an atom such as uranium or plutonium into smaller atoms. This splitting releases an enormous amount of energy. On the other hand, nuclear fusion involves fusing two lighter nuclei, such as isotopes of hydrogen, deuterium and tritium, to form a heavier nucleus, releasing even more energy than fission. This is the process that powers the sun. The sheer power of nuclear explosions makes them a subject of great concern and necessitates stringent international regulations to prevent their use in warfare. The devastating consequences of nuclear weapons have been tragically demonstrated in history, highlighting the importance of non-proliferation and disarmament efforts. Unlike chemical or nuclear explosions, physical explosions don't involve changes in the chemical composition or the nucleus of an atom. Instead, they are caused by the rapid release of mechanical or physical energy stored within a system. A simple example of a physical explosion is a pressure cooker exploding due to a buildup of steam pressure. The steam, unable to escape, causes pressure to build up inside the cooker until the container can no longer contain it, resulting in a sudden violent release of energy. Another example is a tire blowout, where the high-pressure air inside the tire suddenly escapes due to a rupture, causing a small explosion. While physical explosions may not be as inherently destructive as chemical or nuclear explosions, they can still be hazardous. The sudden release of pressure can propel objects with significant force, potentially causing injury or damage. Understanding the principles of pressure and containment is crucial in preventing such incidents.